geometry friends, and welcome to the start of Unit 6. This unit is a lot about triangle relationships and then how those triangle relationships end up leading to quadrilateral relationships. So we're going to start off with some definitions here. So on your paper, this stuff is not all typed out. Let me flip my computer here. You need to make sure you understand the difference between a perpendicular bisector, an altitude, and an angle bisector. So a perpendicular bisector is a line perpendicular to a segment passing through its midpoint. And when it comes to a triangle, I want you to write out this definition. So I want you to write that. I'm giving you time to write. And then if I was going to draw a perpendicular bisector in a triangle, I could draw one to any one of the sides. I'm going to just randomly pick this one. A perpendicular bisector has to pass through the midpoint and make a 90-degree angle with that side. So this would be a perpendicular bisector. All right. Now compare that with an altitude. An altitude is still perpendicular, but it has to be a segment that starts at a vertex and then is drawn perpendicular to the other side. So I'm going to take a minute, write it. A segment from a vertex perpendicular to the opposite side. And if I were going to draw an altitude, okay, usually altitudes are height. So my altitude for this triangle will be that segment right there. It comes from a vertex, it's perpendicular to the other side. All right. Notice the perpendicular bisector does not touch a vertex. It could touch a vertex, but it doesn't have to. An altitude has to start at a vertex and then go perpendicular to another side. And then last but not least, we have this angle bisector, which is hopefully the easiest one. Angle bisector, again, has to start at a vertex, and it has to cut an angle in half. So if I wanted an angle bisector, that would be something like this, where this thing is congruent to that thing. It does not need to cut the side in half. It doesn't have to be perpendicular to a side. It just comes out of an angle and cuts that angle in half. Today is all about a brand new one called a median, okay? If you want a median in a triangle, a median is a segment connecting, again, a vertex to the midpoint of the opposite side, okay? A median connects a vertex to the midpoint of the opposite side. So if you happen to have a ruler nearby, use a ruler for this next part. I do not, so I'm just going to kind of wing it. If I wanted to find a median for this triangle, I'm going to look at the bottom. I'm going to kind of estimate where the midpoint is. I'm going to say it's about there. And then I'm going to connect a vertex to a midpoint. That's a median. Then I'm going to pick another random side. How about this right-hand side? And I'm going to find another midpoint and then connect it. And that's another median. I could even draw a third median if I wanted to. Put that here. And that would be my third median. The medians all intersect at a point of concurrency. Okay, the point of intersection, which is a point of concurrency, of the three medians is called the centroid. All right, so those three medians intersect, and they intersect right here. And this point is called the centroid. Now, we've had points of concurrency before. We had points of concurrency of perpendicular bisectors. That was called the circumcenter. We have point of concurrency of angle bisectors. That was called the incenter. And now we have the medians that connect to what's called the centroid. What's important about the centroid? It is the center of gravity of this triangle if it had like equal density all the way across. All right, so if I were to cut this triangle out on like an index card, if I put my finger underneath right on the centroid, I would balance the triangle. All right, now, sometimes when triangles are acute, obtuse, or right, we have those incenters and circumcenters, sometimes inside, sometimes outside, it depends. So if we were to sketch in a couple more medians here, let's see, I'm going to sketch a median on this one. There's a midpoint, connect to the opposite vertex. There's a midpoint, connect to the opposite vertex. Those medians intersect on the inside. The centroid is on the inside. And if I look at this one, here's a midpoint, connect to that side. Here's a midpoint, connect to that side. Centroid is still inside. The centroid is always inside the triangle. Okay, the circumcenter is the one that can be outside the triangle. Oh, there's stuff on here. Don't look. This isn't supposed to be here. Do, 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 do. Pretend you don't see it. Shh, don't look. Okay. So on here, it says 3 medians of triangle ABC have been drawn in the image. Okay. That's actually information for us, because if I know that these are 3 medians, I know that I have midpoints, and I know they create a centroid. So just the word median gives me information. All right, which point is the centroid? Well, the centroid would be where all the medians intersect, and that would be this point inside the circle. That would be H. All right. Then it says find the following lengths. Oh, I can do that. So CH, let's see, CH is right here. 1, 2, 3, 4. That's 4 units long. HD goes here, count it, that's 8 units long. CD, well, CD would be 4 plus 8, so that's 12. AH, coming down this way, 1, 2, 3, 4, 5, 6. HB, that's 3. And A all the way down to B would be 9. Huh. 4, 8. 3, 6. Do you notice something? I notice something. I notice that 4 is half of 8 and 3 is half of 6. And you know what? It's not a fluke. It happens every time. The centroid splits the median up in a ratio from 2 to 3. A 2 to 1, pardon me. In that the top part is 2/3 the length of the whole thing. The bottom part is 1/3 the length of the whole thing. And the bottom part is half the top part. Now, when I say top versus bottom, that's probably not the best distinction. What I should really say is the part that connects from centroid to vertex is twice as long as centroid to midpoint. And if you don't understand anything I said, we're going to write it again in the box. The centroid theorem says the centroid P of a triangle is 2/3 the distance from each vertex to the midpoint of the opposite side. What does that mean? It means that the part that goes to the corner is twice as long as the part that goes to the side. Okay, so centroid to side equals 1/2 centroid to vertex. And another way to say that is centroid to side is 1/3 the length of the entire median. And this is going to make more sense if we look at some numbers in a second. So get that jotted down. Okay. So now let's use it. Use the centroid theorem. In triangle RST, point Q is the centroid, SQ is 8, QV is 5, and that's marked on the diagram. Find the following. Okay, before I even look at this, don't scribble yours out. Before I even look at what they want me to find, what I really want to encourage you guys to do for all of mathematics, but especially in the next couple of months with the things we're going to do, don't look for what I'm telling you to find. Look for what you can find on your own. Okay, that's how math is going to make more sense to you. Don't find what I tell you to find. Find the things that make sense. And that's what I'm going to do here. Well, if S to Q is 8, the rule was the part that goes to the vertex is twice as big as the part that goes to the midpoint. So if that top part is 8, this bottom part has to be 4. And then the same thing is true. QV is supposed to be half as big as QR, so QR's got to be 10. All right, now let's fill it out. What's QW? That's 4. What's SW? Well, that'll be the whole thing. That's 12. What's QR? That's 10. VR, that's the whole thing, 15. All right. Okay, I want you to turn the page, and I'm going to shrink it. Don't look at it. Okay, and look at that example 4 here for a second. Well, I delete everything, so be reading example 4 here. Bloop. All right. So it says I've got another centroid. Fine. DC is 3x plus 3. Right on the diagram. Right on the diagram. Always put your markings on the diagram. So if DC is 3x plus 3, that means that this whole thing here is 3x plus 3. And DF, just this little part here, is 2x minus 3. Find x, DF, FC, and DC. Okay. Fun fact to remember, when you see something like DF and it doesn't have the bar over it, like this one does not, that means find the length of DF, FYI. Okay, well, couple different options here. Option 1, you remember that like 1/2 double rule. The part that goes to the midpoint is half as long as the part that goes to the vertex. So if this is 2x minus 3, that would have to be 4x minus 6. That's helpful. Option 2 is, remember that this little part is 1/3 of the whole thing. So I could do 3 times 2x minus 3 and say that that equals the entirety, which is 3x plus 3. Okay? Does not matter which way you do it, you're going to end up with the same equation. All right? So 3 times the little part equals the whole thing. Let me distribute my 3 and solve for x. 6x minus 9 is 3x plus 3. Take away the least amount of x's. Add the 9. And get x equals 4. Okay, cool. I found x. Woohoo! Now I got to find df. Well, df was 2 times x minus 3. So 2 times 4 is 8. 8 minus 3 is 5. So df is 5. CF. Well, CF is 4x minus 6. So 4 times 4 minus 6 is 16 minus 6. That's 10. And then DC, which is the whole thing, would be 15. Awesome. All right, and then last but not least, we can use medians and triangle proofs. This is actually very quick. We're not going to complete an entire proof, but now what you need to know is if the word median is used in the given, if you know you have a median, you know you have a midpoint. So if BE is a median, then you know that E is the midpoint of AC because a median connects a vertex to a midpoint. And if you know you have a midpoint, then you know the left part equals the right part. And you know that AE is congruent to EC because midpoints create 2 congruent segments. And there you go. There are 2 pages of practice that follow this, and that is your task next. If you need anything, make sure you look back at your notes. But what you really need to know from this one lesson is that if you start at a midpoint and connect to a vertex, you have drawn a median. And if you draw more than one median, where they connect is called the centroid. And if you have a centroid, you know the part that touches the vertex is twice as long as the part that touches the midpoint. And with that, I am done. I am going to give you a joke today. It's terrible, but you're going to giggle anyway. What do you call a magic dog? What do you call a dog that can do magic? That's really how I meant to say that. What do you call a dog that can do magic? A labracadabrador. Labracadabrador, everyone. Have a glorious, glorious day.